So we do need to revisit discontinuities and definite integrals again. I'd said in a previous video that vertical asymptotes are problematic in that they don't always exist for us. Um, and we have to be mindful of this, especially because when we are working with uh, evaluating a definite integral using antiderivatives, it's very easy to forget to check for vertical asymptotes. And for me, that happens because every other discontinuity is no big deal. I could have a jump, I could have a hole, I can go ahead and integrate just like normal, but vertical asymptotes are, sometimes they work, sometimes they don't. And to give examples of this, I'm going to use 1 over x and 1 over x squared, both of which, both of which have vertical asymptotes at x equals 0. So technically, both of these should not exist. But because 0 is right smack dab in the middle of those. But let's see what happens if I go ahead and pretend like, oh, this is not a big deal. So the antiderivative of 1 over x is the natural log of the absolute value of x, technically, because natural log can only be taken of positive values. So it's assumed that I'm making x a positive number here. And that's from -1 to 1, which gives me the natural log of 1 minus the natural log of 1, which is 0, minus 0, which is 0. And actually, if I type this on my calculator tells me it's 0. But because the vertical asymptote right in the middle, that's not necessarily true. It might be, it might not. In BC, we need more knowledge to be able to tackle how can we see if that's right or not. In AB, we just stop at saying, well, no, there's a vertical asymptote. This doesn't exist. BC will examine more, well, does it? If I look at 1 over x squared, well, that's the same as saying the integral from -1 to 1 of x to the -2nd, which means I can do power rule backwards. So that's negative x to the -1st from -1 to 1, which would be -1 minus 1, which is -2. Well, that's definitely not close. And I will say, if I type this in my calculator says it's like 50 billion. This is most definitely incorrect. -2 is not what I should get. This most definitely does not exist. Because the graph of 1 over x squared looks like this. And I'm saying go from here to here. I shouldn't end up with negative values, period. Whereas when I look at the graph of 1 over x, I could conceivably see it being where maybe this area cancels this area. But 1 over x squared from -1 to 1, I shouldn't end up with negative areas at all. But the definite integral says I do. So you do have to be careful and watch out for, hey, do I have a vertical asymptote?